So this assignment related to the fluid flow, as I mentioned, the first 16 questions already I have recorded session, so I will solve from 17. In question 17, the designer of a new lorry trailer claims it saved 10% of amount of a fuel used to compare a traditional. So that is a traditional trailer, and the new design, you can see it's more streamlined, more laminar flow of the fluid around it. The photograph shows how the airflow around a traditional and the new trailer. Use information from the photograph explain why the new trailer would use less fuels compared to traditional. So first, one mark when you mention about the fluid flow around it. Like example, you can see the new design is more streamlined or more curvy or more aerodynamic. You can use that term, which reduce the air like which reduce the turbulent airflow. There will be turbulent airflow, but it will be like few turbulent flows are there or few eddy currents are there or eddies, and it increase the laminar flow. As a result, it will experience less air resistance. As it experiences the less air resistance, so less energy is used from the like greater proportion of the energy is converted into the kinetic energy and small proportion of the energy is wasted to overcome the air resistance. So less work will be done against the air resistance. So greater amount of the energy will be used or converted into kinetic energy. So the same amount of a fuel, the new design, the lorry or the trailer with the new design can go far distance as it is not using too much energy to work done against the air resistance. So here the old design was having more turbulent flow around it. You can see here more turbulent flow. But the new design, which is more streamlined, it's having a turbulent flow, but small area it's having a turbulent flow. So as a result, what will happen? Less air resistance in the new design, less energy is used to work against the friction or air resistance. So more energy is used to converted into kinetic. So greater amount, like for the same amount of the fuel, it will give a greater mileage or more distance the trailer will cover for the equal amount of the fuel added to a new or the old trailer. When the lamp is switched on, the large drop of a liquid wax are seen to rise and then fall in the clear liquid. As the wax drops is heated, it expands, its density decreases, it rises through a clear liquid. Explain why the wax drop begin to move upward as it is heated. So, like example, say you have a container which is filled with a liquid and there is a wax drop. So when we switch on the lamp, the large drop of a wax are seen rising, they're going up. So what is the reason for that? As you can see that the weight is acting down and upthrust is acting up. So an upthrust depends on the density of the fluid, volume of object and gravity. This density is density of the surrounding fluid. So it's not about the density of the wax, it's about the density of the fluid. So what happened? If we consider the density of the fluid is not changing, when this expands, its size increases. When its size increases, the volume will increase. When the volume will increase, the upthrust will also increase. So it means greater upward force than the downward force that cause it to accelerate upward. So answer the marking point, you will mention that as the wax drop expand, its volume increase and upthrust depends on the volume of object. So the upthrust also increase. Or upthrust is more than the weight plus the drag. So this will accelerate upward. Is it clear, this idea? Because the upthrust equals to density of the fluid volume of object and gravity. If volume increases, the upthrust increases. Weight is not changing. So now the weight is more than, upthrust is more than the weight, that is causing an upward acceleration. Or you can say weight, upthrust is more than the weight plus the viscous drag. Because in this example, if an object is moving up, the viscous drag will try to oppose the motion, so it will act downward. But still the upthrust is more than both of them. As a result, it will accelerate upwards. Is it clear, this one? Then the wedge drop accelerate initially. Lamp is affecting the density, but not too much. Lamp is affecting the density, but compared to the wax, it's not too much. Like not too much change in the density of the fluid. Like, or you can also compare as the upthrust. Upthrust is equals to density of the liquid, volume of object, and gravity. Increase in volume is much more than decrease in the density of a fluid. That's why overall upthrust is increasing. So the wedge drop accelerate initially and then reaches a terminal. Write a word equation for the force acting on a wedge drop when it is moving upward. So when it is moving upward, the upthrust is upward, weight is downward, and the drag force is also acting downward. So we can say upthrust word equations. You have to write. You cannot write just the symbols. It should be a word equation. So upthrust equals to weight and the viscous drag, or you can also say a drag. One mark is for mentioning the name correctly. One mark is for writing the equation correct. The wedge drop is seen to slow down as it reaches the top of the lamp. Explain this observation, like why the wedge drop. So what might be the reason for that? So you can write this answer in two ways, like why its acceleration is decreasing. Here weight, viscous drag, and upthrust. So upthrust is equals to density, volume of object, and gravity. As it is rising, the temperature is lower at the base, the temperature is high, but at the top, the temperature is low. So as a result, the volume decrease, so the upthrust decrease. As a result, the resultant force will decrease. So its acceleration will decrease as well. Or you can also mention the part of a liquid which is colder, that will have a more viscosity. We have the formula for viscous drag 6 pi eta R and V. So the part of the liquid which is having low temperature, it will have a high viscosity. As a result, when it has a high viscosity, so the viscous drag will increase. That's why the resultant force will decrease. So the acceleration also decrease, because resultant force can either decrease if the upthrust decreases, or it decreases if the viscous drag increase, because viscous drag is opposing the motion. So upthrust equals to weight plus the viscous drag, or upthrust minus weight minus the viscous drag equals to ma.